Hello, Flat Earth researchers, debaters and debunkers. This fan will demonstrate for us how we can see the stars appearing to rotate in different directions depending on where we are on a level Earth. Now, if ever you ask a globe Earth believer to defend their belief with a measure of curvature on the surface of the Earth, they cannot provide you with one. Instead, they will point to the stars and they will say that because we see the stars rotating in one direction when we are north of the equator and in a different direction or the opposite direction when we are south of the equator and facing the opposite direction, that is proof that we live on a globe. They say it's only possible if we're living on a globe. But we can see here that if we rotate these fan blades in a clockwise direction, that actually we can demonstrate how we can look at a portion of the sky, and depending on where we are looking on the Earth, we will see that it appears to rotate in a different direction to the direction it's actually going. So what we see in reality is that north of the equator you will see Polaris, and you will see the stars appear to rotate in an anti-clockwise direction. But if you are south of the equator and you've turned around and you're looking south, you will then see the stars are going in a clockwise direction, maybe centered around the Southern Cross. And of course, another assumption with the heliocentric globe Earth model is that the further you get towards the equator, the lower Polaris gets in our field of view until you cannot see it. If you go beyond the equator, you cannot see Polaris. And this is said to be only possible because the view of the sky is being blocked by the curvature of the Earth. But again, what happens is that we only ever look at a portion of the sky, and we can just abandon all these heliocentric assumptions and just see the stars as they appear to be, which is very, very close to the Earth. We could be talking a few hundred miles, a few thousand miles, but in that case, the sun and the moon as well, they will just disappear from our view because we cannot see the entire sky. So if you just assume that this is the entire sky in our camera's view here, above the level Earth, okay, we'll see that when we just look at a portion of it, then we will see the stars behaving in a certain way, depending on where we're looking. So in reality, we can only really ever see a portion, almost half of the sky, that at any one time, depending on where we are. So here I've got some arrows on this blade, and we'll see that they're pointing this direction. So if I turn this clockwise, basically the arrows have come in from the left, okay, and they're going off to the right, all right? And I'll just keep on turning this clockwise, and they will come around again from the left to the right. So it's pointing in the direction that they are going. All right, one more time, and it's going to be left to right. Okay, so that's how we would see the stars appearing to us in one particular spot on the Earth. But then if we moved, and we're now looking at another portion of this, a different portion of the sky, we'll go down here, and we continue turning it clockwise, okay, and as these arrows come in, they're now coming in from the right and going off to the left, okay. Yeah, just now it was from the left to the right, now we're seeing them come in from the right to the left. So we can just follow this round actually, and you'll see that as we go up here, we then get this change where now that we're looking at this upper portion of the sky, it's going from left to right, and as we follow it around, we'll see that it ends up going from right to left. Yeah, it's really simple. Okay, that's basically what is happening when we look at the stars from a particular place on Earth. So let's now use this Big Dipper instead here. You can see that it's kind of got that saucepan shape. All right, so we might be looking at the Big Dipper come across the sky, okay, and everything's fine and dandy as we go clockwise. And then as we take this down, okay, I'm just going to bring this down with it, okay. Now we see that two things are happening. We've got it coming in from the right to the left, but also it's now flipped, okay. We didn't change anything apart from the direction that we're looking, but now we can see that it appears to be upside down compared to where it is when we're looking up the top of the fan blade here, okay. Alright, and the same goes for this one. I've got Orion here, so there's Orion's belt in the center, there's the archer's bow. Alright, so you might see it go across the sky like that for you, but then you might be somewhere else and you'll see it appear to be upside down, okay, but the fan is still going in the same direction. Alright, it's going clockwise, so now it's upside down, and as we follow it, it's now going the right way up. Okay, so we're not really doing anything with the camera apart from just representing a point of view from a different location on the surface of the Earth, looking up at the stars, and our particular field of view will be different depending on where we are looking from. Alright? Now, let's just talk about how that happens and in relation to day and night. Okay, so let's assume, regardless of the mechanics, that all the stars are rotating above us at about a similar distance as you see them on this fan. So we're looking at the entire sky now from a flat Earth perspective, okay? So let's now introduce the sun with this torch to the scenario. I'll put the torch representing the sun behind these blades. So we've got the stars basically on some kind of disc or whatever it is above us, all about the same distance from us, rotating above us, okay? And then we have the sun at maybe a slightly different distance, and it is also rotating, okay? So we've got these two things that are rotating at slightly different rates, all right? So while the sun goes around like this, we also have the stars going around, but because they're going around at a different rate, then we'll see stars or not see stars depending on where the sun is at different times throughout the year. So this gives us the seasonal changes of the stars that we see in the sky depending on our location, because the sun is local and rotating at a slightly different rate. Then it will be lighting up the sky where we sometimes have stars and other times where we don't have stars, and that would allow you to see different stars at different times. I'll just turn around and put it over here to re-illustrate the point, okay? So here I've got, and let's zoom in as well, okay? We've got our hemisphere, as it were, but it's a hemisphere of the celestial sphere. All right, so for example, okay, we can see that we've got a local light, okay, so over here of course it's daytime, we've got the sun in the sky and it's making everything light. Over here we've got Orion, and that will be visible of course because it's in the darkness, but when Orion comes into view into the light, then we can't see Orion anymore. And as they rotate at slightly different rates, then we'll see Orion while it's dark up here and light down here. Okay, all right, so the sun is doing that, and when the sun is in the sky, of course, we cannot see the stars. Same thing here, okay? So they're rotating at different rates, and that gives us a different view of the night sky throughout the year. Again, it's just a case of breaking free from that heliocentric understanding and understanding that the stars are local, the sun is local. You see just a portion of the sky, and it changes throughout the year because both of these things are rotating, and we're on a level plane watching all that happen in the big clock in the sky above our heads. All right? Yeah, so it's just, you know, got this local light here. The heliocentrist will say, oh, the sun would light up the entire flat Earth, but they're imagining a big sun that's very far away. But if we just make it a local sun, then you'll only get a portion of the Earth lit up, and as the stars pass through where the sun is, then you don't see the stars. And then you get the night time and you see the stars. And this is rotating as well, okay, but slightly different speeds, so you'd see stars at different times. Thank you very much.